This is Dr. V. Naganjanelu, Associate Professor, Department of Mathematics, Vardhaman College of Engineering. Course is Matrices and Calculus. Present topic is change of order of integration. How can we do change of order of integrations? Sometimes evaluation of double integral in the given order is impossible, means we will feel much difficult to evaluate that integration. In this case, we can adopt the change of order of integration, which we can evaluate the double integral, which is by easy way. If the limits are integrating or variables, the change of order of integration requires the change of limits of integration. This can be done by drawing a rough sketch of the region and changing limits of accordingly. We need some knowledge on drawing the graphs. These problems we will discuss on whiteboard. Let us discuss question number 1. Evaluate integral 0 to infinite integral x to infinite e power minus y by y dy dx by changing of order of integration. First, decide the limits. Solution: integral 0 to infinite integral x to infinite e power minus y by y dy dx is equal to, I am deciding the limits. Here x given, so that integrate you take as y is equal to x to infinite, and the rest is x is 0 to infinite e power minus y by y dy dx. Now x is a constant in 0 and infinite, y is in the limits of x. After changing order of integration, it will come reverse. X in limits of y and y is constant limits, you will get it. For that, you need the diagram, x-axis, y-axis. Now here you will get x is 0. What do you have here? X is 0, x is infinite, y is x, y is infinite. Let's make the rough diagram. X is 0 in the sense it is, you will get this y-axis, and x is infinite means from here to here you will get it, that we will see. And okay, if you want you can make like that. Okay, now y is x, y is x we'll get by, I'll change the color. This is y is equal to x, this is y is equal to x. Now y is infinite, let's take the another color. Y is infinite, this it will come down also, but intersection part of this is this, means you are going to get here and this and this. That's the diagram. Now I denoted x is 0 and x is infinite, y is x and y is infinite. Now I need this intersection part of green, this intersection part of yellow and white lines. By changing order of integration, we get now x is 0 to infinite, constant limits, y is this value. We get y is 0 to infinite and x is, you will get it as x, this is 0 0, y is 0 and y is infinite, and this is x is 0 and this is x is y, 0 to y. This the yellow color two lines plays very vital role in this problem. So according to the diagram, I have changed the limits. Now we'll write double integral x is 0 to infinite, y is x to infinite is changed as e power minus y by y dy dx is equal to, this changed as like integral. Now y limits, y is 0 to infinite and x is 0 to y e power minus y by y dy dx. Look at here, x limits are constant, y limits are in x. After change of order of integration, y limits became constants and x limits in y. Now you can start the integration. When x is there here, you will get here dx. So just a minute, you can change this as like dx and dy. Okay, this is dx dy. Now evaluate this integration. Now dx dy, evaluate this integration is equal to, first with respect to x, you are going to get integral y is 0 to infinite e power minus y by y. It is a 1 dx. You are going to get x, and x limits are 0 to y dy. Substitute upper limit. Integral y is 0 to infinite e power minus y by y. Upper limit is y, lower limit is 0, not required, into dy. Now y will be cancel. You are going to get that is equal to integral 0 to infinite e power minus y dy. That is equal to, what is e power minus y integration? Is e power minus y by minus 1. 0 to infinite. 0 to infinite will get minus 1 into e power minus infinite e power minus 0. It is nothing but minus 1 into 0 minus 1 is nothing but 1. So what is this region of this given area is 1. Problem 2. Yeah, problem 2 is evaluate integral 0 to 1 integral x square to 2 minus x xy dx dy by change of order of integration. Now coming to solution, integral 0 to 1 integral x square to 2 minus x xy dx dy. I am going to write it as integral xy dx dy. These are the limits. Here x is available. So it is y is equal to x square to 2 minus x. The rest is you are going to get x is 0 to 1. Okay, x is 0 and x is 1, and y is x square. Y is equal to 2 minus x. Simplifying this, x plus y is equal to 2. For diagram, make one step like x value, y value. If x is 0, y2. If y 0, x2. So let's move to the diagram. The diagram gives here x axis and y axis. And first I am drawing. This is x is 0 and somewhere x is 1. Okay, if you think it is a 1, if you think it is a 2. Next, y is x square. Where is y is x square? It is a parabola. This is y is equal to x square. Okay, now the next is x is 0 to y is 2 0. So here this is 0 comma 2 and this is somewhere here. If it is 1 with equidistance, then this is 2. Then you are going to get this name is x plus y is equal to. There is beauty here is the intersection point. Look at this intersection point. All are meeting at 1 comma 1. So this point is y is 1. This point is y is 1. Here we have two regions, namely is R1 and R2. R1 and R2. So you have to find the region of these, like this, and another one like this. So by change of order of integration, the given region splitted into two regions, namely double integral R1 xy dx dy plus double integral R2 xy dx dy. Then what is R1? Now here let me know about R1. R1 in the sense you are going to get this as this is R1. So y is starting from here 1 2. This line is x plus y is equal to 2. So you are going to get that value is y is equal to that value is y is equal to, let's identify the constant limits. At x is constant, then y should come the constants. So y is 0 to 1. Okay, we got it. Y is 0 to 1. Okay, and what about x limits? X is equal to, you are moving from here to here. This is x is equal to 2 minus y. Y is equal to 1 to 2. Make it R2. Take it. Start. By changing order of integration, the given region divided into two parts, R2 and R1. R2 means here it will start from 0, 0, 2 and this line. So you are going to get, it is double integral. Let's make the integrations. Like you are going to get y is 0, 1, y is 0, 2, 1 and x is this. At one parabola you are going to get x is equal to 0 to square root y. How I got x is 0 to square root y is, they have given y is equal to x square, then you can make x is equal to square root y. Then as it is, you are going to get x, y, it is a dx is there, dx, dy. Now plus, coming to R2, the R2 gives the limits, this or R1, the R1 gives, and here y is constant limits means y is 1 to 2, that is okay, 1 to 2, simple. And here x is moving from here on y-axis, x is 0 and it is moving from here to here. Then x is 0 to 2 minus y. How we got it? From this, we know x plus y is equal to 2 and x is equal to 2 minus y. Now you will get x, y, dx, dy. It's complex. One, the region. The given region divided into two regions, namely R1 and R2. So once you identify this, and what is the intersection point of three curves, y is equal to x square and x plus y is equal to 2, and one more is x is 1, then you are able to understand this region. So next is evaluation. Let's move to evaluation. Integral y is 0 to 1 and x, y, dx, dy, in the sense y as it is, x dx will become as, x dx will become as x square by 2, and you are going to substitute 0 to y into dy, plus integral y is 1 to 2 and it will become y into same x square by 2, 0 to 2 minus y into dy. Now equal to y is 0 to 1 and y into upper limit is this, square root and square will be cancelled. You are going to get y by 2 dy, plus integral y is 1 to 2 and y by 2 you take it out and you will get 2 minus y whole square dy. Now it will become as y is 0 to 1 y square 1 by 2 y square dy, plus integral y is 1 to 2, please multiply, 1 by 2 is outside, and y it will become a minus b whole square, 4 minus 4y plus y square into dy. I evaluate this 1 by 2, you will get y cube by 3 and the limits are this 0 to 1, plus integral y is 1 to 2, please multiply, 1 by 2 is here and you will get 4y minus 4y square plus y cube into dy, that is equal to 1 by 2, upper limit is 1, so 1 by 3 plus integral 0 to 1, then take the integrations, 4y dy gives, I'll change the color, this gives 4y square by 2 minus 4 y cube by 3 plus y power 4 by 4, and it is 1 to, the limits are 1 to 2. Then by substituting upper and lower limits there, you are going to get like equal to 1 by 6 plus 1 by 2 into what is upper limit 2. So this 2 cancel and one more 2 is there, 2 into 2 square 4, so it is 8 minus 4 into 2 cubed is 8 by 3 plus 2 power 4 16 by 4, that is upper limit, okay, minus what is lower limit is 1, so you are going to get 2 minus 4 by 3 plus 1 by 4. By final simplification you are going to get this answer is 3 by 8. Thank you.